Hi students, morning. So today's topic is about operator overloading. So you have seen how to use string operators in the last lecture, but before that, you have seen that some operators can be implemented as global functions, and some operators can be implemented as member functions. So it depends on the symmetry of the operators. And the symmetry is not implying the equality. It means the validity of something. So we'd like to use that fact today. And the overloading implies that the name, some name, has multiple roles. So name and role. So you may think about that these roles is called can be considered as an actions or procedures or functions in C++. The same fact can be considered as a plus here. So think about that. Plus has a role of integer plus, integer sum, and it also take a role of double sum. It is different in the perspective of the implementation on top of a computer. So can you tell me the reason? So I said the role is like a functions. Think about that you are implementing integer sum. So how can you write the function? Maybe sumint. Sumint is a name, and it may take two integer parameters, a and b, returning the summation. How about the second? Summing up two numbers in double. It should sum of two double numbers. Double y, okay? And what does it return? So you know that the plus is actually overloaded for two functions, okay? Plus is overloaded. The first row is sum of ints. This function is necessary for plus. How about the second one? You need sum of doubles. So in that respect, you know that plus is overloaded. It has two rows. So you know that plus is overloading. The first row is sum of integer function, and second row is sum of doubles function. In that respect, this plus truck is loading. Some part of it is a sum of integers. Some part of it is sum of doubles. So you may overload further if you want to add them to natural numbers. Okay, so you may overload them, such as it should return natural number and sum of nests, accepting your first natural number n1 and second natural number n2. So this is another row. So you may overload this plus. That is the issue of today. You can still use stream operators such as extraction operators, this one, for input, and insertion operators, some output. But the left-hand side or left-hand operand should be the streams IO streams. So for input I stream object, in some case, in a typical case, it is cin. So you may apply some n extracted from your cin. And for another stream is O stream, which means output stream, and one instance is cout, and you can apply that n plus 1 maybe put into your output stream. So it is called insertion operator. So it is very robust because it accepts only valid types. You know that if it is declared as an integer, it is valid for cin and cout. Okay, but the scanf does not check the validity. It just accepts the address of, which is a pointer, and printf is the same to the scanf. So it accepts arbitrary variable, but it does not check the type of them. So in that respect, C stream is not so robust than C++ stream. Okay, do you agree on that? Bino or Subin, do you agree on that?
Yes, I agree.
Okay, so the robustness is hard to fail, but using C streams in the last lecture, you have seen that it is easy to fail. Okay, so today we want to review character-based input and output, line-based input and output, and operator overloading at last will be explained. So CVS and C++ streams. So you know that this is just a review. So it is just accepting the address of, okay, and for printing, it is just accepting some integers, but it is assuming that they are integers. So if you make another natural number, net n2 with n here, then you may pass this as n2, not knowing that it is not an integer. Then it may print n2, but sometimes it will not print. Okay, if n2's implementation is changed. So this is a failure. You have to pass n2.ivan, okay, which is returning a real integer. This is good. It is not a failure, but this is a failure. But that kind of failure is not caught in your C version. Okay, so but in your C++ version, you have to, if you pass n2 instead, it complains. So that is the key. How about that print? That print.cpp. So include IO stream. Just forget about manipulators using namespace std. So you have to declare a struct net whose member is just an integer a. And your main function, you are declaring integer n whose value is 1, and you are declaring natural number m whose value is n. So while cin n, it would like to, okay, this is not needed for this. I'd like to just print the contents of n, underline. Okay, and I'd like to print the contents of n with underline. But you know that the second one is not valid. Okay, but without IOStream, if you're using, so let me just load cstdio. This should be replaced by printf sandy n. Okay, and this should be replaced printf sandy n. Okay, but it will print both 1 and 1. Let me just make it. This is an error, sorry. So you have to initialize it with initializer list. Okay, so let me just check it again. It compiles fine, okay, compiles fine. And actually netprint will print 1 and 1. But this is wrong. I insist this is wrong because you know that the first one is okay because it is a natural number. But how about, let me just make another implementation of B, B and A, and you want to initialize this 0. But with the semantics of net, it should print n, 1, okay? But know that it compiles fine, and net print will print 1 and 0. So this is a problem. Can you get the problem? Let me make it more clear. If you make this as class, default in, this is default in private, okay? You want to make a public constructor accepting an integer n, okay? And you know that A is initialized by n, but B is initialized by 0. Okay? But so you may write this as n here. So what should be printed for the second? It is a natural number constructed with a value of 1. How about 2? What should be printed for the second? But let me see. Is 2 is printed? Final value is not called by printf version, but it should be called by cout version. Okay. So with cout version, you have to use IOStream using namespace. Okay, so let me just make it again, net print, but it will complain because the second one is not defined. You cannot print a natural number to the alpha stream. So how can I print it? So you have to supply some value should be returned from the natural number. So you have to supply them. M is not valid, but the integer value should be printed, can be printed. Okay? So this is really true. So make net print. It is good. And that kind of version is also good. If once you know the error, you can use it for CSTDIO. Okay, for CSTDIO. So let me just print it again. Printf %d, and it's okay. How about the second one? m.ivar should be printing. Okay, this is the correct version, but your C compiler does not check it. Okay, so in this correct version, netprint will print 1 and 2 as expected. In C, you have to accept character-based IO, but you know that get character may return error code. It may return error code for the end of file, so you have to supply the variable as an integer, even if C is a character. Okay, so you have to use get character. This should be converted in your stream IO with .get, scene.get. This is good enough. And since it is safe, you can still use character variable. td in your main function, you can declare the variable as a character. This is important. And while scene.get is valid, you are using cout c. That's all. Okay. So make character IO. So in your character IO, you can supply character IO.cpp. It will print the contents of it. Okay. So how about the input-output stream for string IOs, line-based? So in your C version, you have to use fgetString for input. It is accepting the buffer as the first parameter, and size for the second parameter, and third one is the file stream. So in this case, it is standard in. And output string is for output, and the order is similar to fgetString, except that size is not supplied. Okay, so this is a line-based IO in C version. You are expected to learn this from your C course, and you are using getLine function. Because scene is denoting the standard in, it does not need the third parameter. Okay, so it only accepts the buffer here, the size here. Okay, and C buffer should be printed as normal. Okay, let me just read character.io.cpp again. So just this line should be changed. Character VOF 81, integer size of VOF, size of VOF. Okay, so you are just calculating 81 here. So in your line base, rather than get, you have to use get line, and VOF size should be supplied as additional parameters. Okay, since it is line-based IO, your VOF is printed and the line. Okay, so it is very similar to character-based IO, but you are reading a line by line. Okay, so that is the difference. Make line IO. So it seems that line IO.cpp will print the same thing as before, but you will get to know that this is really a line-based one. If you add a line number, initialized by 1, and you want to print it set with printed line IO, line number. It is auto-incremented. Okay, and should I separate this? Some of the spaces here. And then you'll get to know the effect of line-based IO. So let me make it line IO. Know that line IO is accepting line IO the CPP, printing the line number. So let's jump to the operator overloading. So you know that how does C++ knows the special meaning of extraction? So the special meaning of extraction, this is actually can be interpreted operator and input stream and variable. Or in asymmetric implementation, Cin operator as a member function accepting some variable. Yeah, let me just, so the extending the meaning of the operator is called operator overloading. So only existing operators, including the stream operators, except member access operators and scope resolution operators and conditional operators, and sizeof operators, those operators cannot be overloaded. And other than these four, you can overload them. So let me just decipher that the meaning of this. What is the meaning of this cout of n? So it is extended as operator. This one, you know that this is the operator name. And cout n. Or either this one or this one, cout dot operator n. Okay, so you have to consider that these two operator extraction as a unit. Okay, this is a unit of name. Operator insertion. These are the function names. Okay, so this name is very special. Operator symbol. So edit netprint the CPP. We have seen this print before, okay, but you need ival here for printing integers, printing natural numbers. But it is not needed once you overload the operators. Okay, so let me just write this in this manner. If you overload string reference operator, this one, to all stream reference out a natural number and you can just return out n.ival. This is okay, but this is also okay. M. Since you extended the meaning of operator. So you may still use this safely, just like it is a variable. Okay, let me just check it. Make netprint. It does not complaining. Okay, do you see that? So let's execute this. net print 1 and 2 is printed as expected. So I implemented GCD in an asymmetric manner in this, but I just overloaded operator something, then you are safely using A and B for natural numbers. And A.gcd, which is returning a natural number, it can be output safely. Okay, so this is just an exercise for extending your GCD program. So overloading stream operators is easy. Oh, sorry for that. This should be uh, noted as a code font. Sorry for that. This should be code font, and this should be code font. You know that this is this one and this one. So for allStream, since C in and C out are the instances of iStream and allStream respectively, you may use this operator once the operators were overloaded for those iStream or allStream objects. The following code shows an example of overloading the stream operators with the classnet. Actually, the output operators only. It is very similar to that, this one, okay? And I just added another operator plus assignment. You know, the plus assignment is an asymmetric nature. So I implemented it as a member function. Okay, so you just use these plus operators here. So let me just rewrite some of them. So you know that this is a left associative. So you have to check this one first. So I have to extend this. This is not extended by myself. How about this? It is left associative. So it means that operator, this one, with C out, with N. Okay, so it safely calls this one. Okay, O stream out, N. So C out is transferred to here. N is transferred to here. And it returns output stream. So for the second case is this, is operator, another operator called, whose first parameter is this, and second parameter is this one, up to here. Should I write another color? How about the third one? The third one, operator. This is the first parameter, and second parameter is N. Should I use another color for the last one? This one, operator. Its first parameter is the function, return the value of the functions and the line. Okay, so this is actually expanded to the sequence of function calls in this way, in these ways. So how about this one? So let me use another color again. I have some limited colors. So how about this one? It should be expanded that n dot operator plus assignment n. Okay. So I heard from your TA that most of you have already solved the problem. So let me just summarize today's contents. So I think it is important to give you more time rather than the explanation. So the various examples was explained: formatted IO and character-based IO, line-based IO. So you can use these functions for C stream and C++ stream. For C++ stream, for character-based IO, you can use c.get or cout.put. But I just used cout normal insertion operators. And line-based IO, you can use C in that get line. And you have learned operator overloading, and you cannot change the arity and the precedence and the associativity, those properties of the inherent properties of the operators cannot be changed by overloading. And for operators, including dot and scope resolution, conditional, and sizeof operators cannot be overloaded by operator overloading. So the secret of these operators, stream operators here, that those operators are overloaded for your input and output. So do you know that those are bit shift operators here, and those overloaded for insertion and extraction operators. And you can use that operators overloaded for your natural number. And some question is that, what is the difference of the implementation of A and B? For the symmetric or global implementation, those is overloaded operator plus A and B. But for member functions, you should remember that this first left operand is an implicit operand for the operator plus. So operator plus B. So for the member function, it cannot accept two parameters instead. So you just accept just a single parameter. Okay. So are you overloaded? So actually your C++ is overloaded instead of you. So that's why today's problem is very simple. So do you have any questions up to here? No questions? Then thank you for listening up to the long period of lecture.